Right, thanks everyone. I'm James Thomas from the University of Bristol's Gene Golding Institute for AI and Data Science. This talk is Can Others Reproduce Your Results? It's going to attempt some live demo work, so there's the potential that lots could go wrong. So let's hope it doesn't, but that's like part of the fun to see whether that happens. The take-home message is that if you haven't used UV or pixi before in your projects, I think you should give them a go. So how am I going to argue that? Well, I'll talk about what UV and pixi are, what can they do. I'll talk about some of the common pitfalls that I've encountered whilst using pip and conda, the sort of more traditional tools that people use, and how these are addressed when you use UV and pixi. And then we'll look, depends how much time we have, on some practical steps and recipes for using them in your projects. Now, the slides are available in advance. If anything goes wrong, there's also a pre-recorded version of some of the demos. There's a QR code. It will be up again at the end. So first of all, what can UV and pixi do? Well, they share functionality with a number of other tools, some of which are built into Python or built into your package manager. But then there's some more sophisticated dependency management tools that some of you may well use, and I'll show how they compare. So like the traditional VM pip combination or conda, you're in that kind of ecosystem. They create virtual environments, they install packages. If you're only working with PyPI packages, then I would advise you to use UV. If you're in the conda ecosystem and you want to work with CondaForge, then use the pixi tool. If you've used a tool like Poetry, pipm, pip tools, things like that before that do dependency management, UV and pixi work in the same way. So they allow you to produce reproducible dependency installations. That's what some of the previous talks have hinted at. And they do this using a lock file approach. More on that in a little bit. If you've used pyenv to install and manage multiple versions of Python at the same time on the same machine, they do that as well. And if you've used a tool like pipx to install a Python-based tool system-wide so that you can use it anywhere at your terminal, they also do that. And there's some other special things in there that I won't go into, like a shared cache that means that these virtual environments are very quick to create and throw away, and sort of they're effectively disposable. So I'll start with some motivations for using better tools. Why are the tools that come built in sometimes slightly lacking? Well, let's start with why wouldn't you just use pip? One of the problems that I've encountered with pip is that if you're not careful, you can install incompatible versions of dependencies, and this happens generally if you don't install things at the same time. Quite a common pattern I see that beginners do is they will pip install a requirements file that a project uses, and then later on they'll think, oh, I need to use another tool. So they'll pip install that. That can then break the whole environment, and then there could be incompatible package versions installed, and it's hard to kind of get out of that. But then it's also difficult to keep track of the direct dependencies of your project. So what libraries, what packages do you actually intend to use? And then what are just all the other dependencies that are dependencies of those packages that you've got along the way? If you use a traditional tool like pip and you freeze your environment to a requirements file, it's difficult to keep track of that. So this is where I'm going to attempt a quick demo now of how that might go wrong. So I'm in like a sort of test system here. I've got Python installed, a slightly old version of Python, Python 3.10. In the directory I'm in, I have a myscript.py file and a requirements.txt file and a virtual environment in the .vm directory that I've already created. I'm going to cat my script.py, see what it does. It uses the binomial test function from the scipy.stats package to sort of simulate that we're doing some kind of statistics. I'm not a statistician, but what we're doing is we're flipping a coin 10 times and we only observe one head. We're going to come out with some kind of p-value and see whether we think, is that unexpected? Does that give us evidence the coin might be biased? Let's have a look at the requirements file. Requirements. So the two requirements I've got are NumPy and SciPy. So I'm using SciPy, but for some reason I've got NumPy there as well. So we'll start by stalking. vn bin activates. So we've got our environment going. I will pip install -r that requirements file. And once that's done, I will run Python myscript.py to verify that it works. Yeah, and the UI's gone a bit weird there. Let's run that again. We get a p-value of 0.021, which is the number that's going to keep coming up. That tells us, if you're interested, that this is quite unexpected. This coin we're flipping is probably biased.
I interrupt you for a second. We have a question. It says, what tool did you use for your presentation that allowed you to run it?
I'll do that at the end.
Okay.
Yeah. So let's now say, we're going to do what the other user did. Let's pip install matplotlib. Okay, so it's installing matplotlib, it's upgrading some other packages, installing them. But you'll notice that it's changed the version of NumPy. So if I was to scroll up, we will see that where are we? So we've collected matplotlib at the top of the screen here. Okay, this is the live demo going wrong. Right, what's happened in the middle of the screen here, you can see that it uninstalled NumPy version 1.21.6, which is what we had, and it's installed a newer version of NumPy 2.2.6. It's given us an error message, but it's saying that pip doesn't take into account all the packages that are installed. This might be the source of dependency conflicts, but the key thing is it didn't stop, it just carried on. So our environment is now broken, and if I type Python myscript.py, we get an exception and a traceback. It doesn't work, and we end up with a value error that says somewhere in it may indicate binary incompatibility. And what happens is that we've upgraded NumPy because matplotlib needed NumPy, but then now it's not compatible with the version of SciPy that we've got installed. Okay, so that's it going wrong. Okay, why don't we just Conda? Conda's got this better solver that can handle those dependencies slightly better. And also in recent years, it's got faster because it's got this thing called libmamba. There's lots of names of snakes everywhere because it's Python, of course. So yeah, why don't we use that? But you've still got the same problems keeping track of those direct dependencies. Not everyone wants to use Conda. And what I'm going to show you now is actually developing across different platforms can be difficult as well when you use Conda. So let's go into a little bit of a Conda demo now. I'm in a different environment, so we've got this myscript.py file there, but we've also got now, instead of a requirements.txt, we've got an environment YAML file. So let's cat the myscript.py. It's probably be the last time I cat this file. It's the same more or less every time. Let's cat the environment.yaml file. So it would have been similar to what the requirements.txt file looked like before. So we just specify our dependencies, but because Python is a dependency, in Conda, it's just a package you can install. It's also specified there. Because I've called it environment.yaml, I can just type conda env create. That will create the new environment. It will automatically pick up that environment.yaml because that's the default name. And it takes a little bit of time because it has to download all the data about all the packages from CondaForge, which is what it's doing now. And it's downloaded, and now it's installing the packages. So we should shortly have Python, NumPy, and SciPy. Great, so let's fix the terminal again. So we've got a little message saying to activate this environment, use conda activate. So let's type that, conda activate my env. I can check what version of Python I've got, Python -v. Okay, I've got 3.10, that's all I asked for. I can run my script, Python myscript.py. Okay, I get same output, it's 0.021 p-value. And then probably at some point I install some more packages and I do conda install something and I think, I should probably update that environment YAML. So I'll probably run something like conda export and I'll redirect that into environment.yaml. Let's have a look, see what that looks like now. So cat environment.yaml. Right, so it did just have Python, NumPy, and SciPy in. Now we've ended up now with all of the sub-dependencies. So it's a much longer file. And there's a slight problem hidden in this file. if you look at some of the packages, you've got the package, then you've got a version number, and then you've got a build specification afterwards. And because some of these are binary packages, you'll notice something like Linux 64. This is a Linux 64-bit machine that I'm running on. So this is going to cause a problem if we're working with developers on different platforms, different architectures. Just to show an example of that, let's say that now I'm working with someone who's using a Mac. They push some changes to GitHub, and I'm going to pull those down now. So I'll go git pull. Let's pretend that I'm getting some package changes in. And I can see that, okay, so what my co-developer has done is they've edited that environment.yaml file. So I'm going to update my environment to match what they had. And I'm going to do something like conda env update. So that will update my packages to match the file. And I want to get rid of packages that are no longer in the file. So I'll go --prune. This will sort of get started, but then we'll fairly immediately come up with an error saying that, okay, so the following packages are not available from the current channels. It just lists the first package, which isn't particularly helpful. But if we go and let's tap the environment.yaml file again, if we look at the packages that are now in the dependencies list, you can see that some of them say things like OSX ARM64. And then that's the kind of the problem that you have. And this is a problem that colleagues where I work have experienced this as they've been working across different platforms. So how do these tools that I promised to talk about, UV and pixi, make your life easier? First of all, they split that intent from the packages that you wanted, you intended to install, from the packages that you ended up with, just what all the sub packages are. And this is familiar if you use things like tools like Poetry, if you use things like Node in the JavaScript world, they do this kind of in a similar way. So you have this configuration or manifest file called, in the case of UV, pyproject.toml, or in pixi, you might have a pixi.toml or a pyproject.toml file. And then you also have a lock file, which contains, so the first one is what you intended to install, the lock file is what you ended up with everything else. It's kind of the frozen dependencies. That's uv.lock or pixi.lock. Once you're using the tools, the kind of standard pattern for most kind of setting up a project is init add run. So you'd run uv init or pixi init, uv add will install, pixi add will install a package, and then you run using uv run or pixi run. So a few things to point out here are when you run a script, so either in UV or in pixi, you don't activate the environment first. So the standard pattern is that if you're in the project directory, you use UV or pixi to run Python, the environment will effectively be activated for that function, for that command call. There's a few slight differences. So if you want a specific version of Python, in UV, you specify it on the init line. In pixi, you specify it as a package. That's slightly different. In UV, if you're just running a script, you don't need to say UV run Python myscript.py. You can do, but UV knows if it ends in .py, it knows you're trying to run a Python file. In pixi, you have to say pixi run Python myscript.py. And there's a few other niceties that I won't go into, but it's in this kind of full list of slides if you want to see some of the main differences between the two. So now I'll show an example of what it looks like when you do use UV to accomplish what we did before that went wrong. So I'm on a system here where, just to clarify, I don't have Python installed. I don't actually have UV installed either. So first thing I'm going to do is go to the UV website to download it. So I'm on the UV website now, and if I scroll down, I find this curl piped into shell line. You might, because you all, I'm sure, know what you're doing, you might not like to do this. There's other ways of installing it. I'm happy to forgo the security sort of risk of doing it this way, and I'm going to paste that command into my shell. That will download UV and install it, and it will just give me a little message that says, okay, in order to set up the path correctly, you probably want to restart your shell. So I'll do that now. So right, I've got UV, and all I've got is that myscript.py file. Firstly, I'm going to type UV init, and I'm going to request the same version of Python I had before. So Python --Python 3.10. Okay, that was quick. What's that done? Let's list the directory. It's created a few files. It's created a .python version file, created a README file, a main.py file, which is the demo, we pitched that file, and a pyproject.toml file. Let's just have a quick look at the pyproject.toml file, so at pyproject.toml. This at the moment basically just contains metadata about the project. So there's some information at the top here. The version of Python that I requested has been put at a minimum constraint as the file under requires Python there, and there are currently no dependencies. If I cat the .python version file, that literally just contains 3.10. That's the version that I wanted to use. We can check that we've got that version of Python installed by going uv run python -v. Okay, well, we didn't have Python installed, so uv will go off and download a version of Python, install it in a location, and then we've got the output. Okay, so that version of Python is now already installed. Let's add those two packages that we had before. So uv add numpy, and I use double equals to specify exactly version 1.21.6. That's what we had before, and scipy version 1.7.3. So we'll go off and download those and install them. And then I can run uv run myscript.py just to verify, okay, that works, that's what we expected. What's that actually done? So I'm going to list the directory again. We've now got a virtual environment in .vn that's been created. The pyproject.toml will have changed, and there's now a uv.lock file that's appeared. Let's have a look at those last two. So let's cat pyproject.toml. All that's happened is the dependency specifiers, like in a requirements file, have just been added. And let's cat the uv.lock file. This is somewhat different. So this is another toml file, but it contains all of the URLs where all of the different versions of the dependencies can be found. So here we've got numpy, and it's this version, and these are the URLs of all of the wheels. I can't open. And then if you scroll to the right-hand side, you'll also see lots of cryptographic hashes. So these are used to check the integrity of package downloads and to check that you've got exactly the version that you had before. So that's kind of an important thing for reproducibility. The key thing here is you would never edit this file by hand. This is managed for you by UV. If you were going to version control these files, then you would usually version control in a kind of a project. You'd version control the pyproject.toml, the uv.lock, and the Python version. If you were making a package, actually you don't want to be that specific of what other package versions people use. You would just version control the pyproject.toml. I'll quickly demo what went wrong before. So uv add, what did we add? We added matplotlib. So it's gone off and it will have found a version of matplotlib that's compatible with the existing dependencies that I've got, and uv run myscript.py will work. So just kind of verifying that actually it does work that way. So we installed uv and we use the init, then we use add, then we use run. Let's do the same thing with pixi now. So I'm sure you believe me, don't have Python installed, don't have conda installed, don't have pixi installed. So none of those things are there. Let's go to the pixi website now. And I think installation on the left, we've got another one of these curl lines. Let's use that. So let's paste that in. Okay, that's downloaded pixi. And again, please restart our social shell. So let's just restart. So list the folder, myscript.py as before. Let's run pixi init. So as kind of with UV, this has created a pixi.toml file. Let's have a little look at what that looks like. So let's cat that. Okay, it looks very similar. We've got that kind of similar metadata. We do have a note that it's picked up that I'm using Linux 64-bit at the moment, and there's no dependencies specified. So let's add some. Let's add Python. So pixi add Python single equals 3.10 is the conda way of saying any compatible version of that. So that will still have to download the conda Borge list of packages, which it's done. Then it will download Python, and then it will install it, and that's done. So I should be able to run that. So pixi run python -v. Okay, we've got 3.10 installed. let's add those other dependencies that we had. So pixi add numpy double equals, we're back to 1.21.6 and scipy 1, this is why I need the notes, 1.7.3. So they'll be downloaded and installed. And just to verify again, pixi run. Oh, I need Python this time. Pixi run Python, myscript.py. Okay, and it's working. I'll just have a little look at what's happened as we did with UV. So we've now ended up with a .pixi directory. We also have to show that there are some default Git configuration files it adds, which I'm not going to go into. And then we've got a pixi.log and a pixi.toml file. So let's look at what's happened to the pixi.toml file first. So cat pixi.toml. So in a similar way, the dependencies are just added at the bottom. So you can edit this file by hand if you want to. And cat pixi.lock. In a similar way, this lists all the URLs of all the packages that are installed in the environment. And if I page down just to a random place, you can see that there's also all these cryptographic hashes again. And this file is a bit longer than the uv.log file just because of the way it's formatted, but we're up to almost 450 lines. We've only got 2 or 3 packages installed. But again, you don't edit this by hand. So we had the problem of multiple platforms before. I'll show you what to do in that case. There's a command called pixi workspace, which edits all the configuration associated with your project. And there's a load of, I mean, if I scroll up, there'll be more suggested commands, subcommands here. The one I'll be using is platform, commands to manage workspace platforms. And I'm going to type pixi workspace platform add, and I'll add OS X ARM64, and I'll add Win64 because I'm on Linux 64 at the moment. So it has to download different CondaForge data for those and work out what versions of packages would work with all 3 architectures now. And if I cat pixi.toml to see what's happened, it's literally just changed this platforms line here to add those in. But what impact did that have to the lock file? So cat pixi.lock. Okay, well, it looks pretty much the same, but you know, we had Linux 64 here now. And if I scroll down, you'll see there's a section that says OS X ARM64, and there's a Win64 section as well. And we're now up to almost 1,200 lines in the log file. So it's kind of got 3 times as long, which is what we'd expect. So that's like the basic, how do they work? There are some kind of quality of life improvements that I'll just show as many as I've got time for, and Nick will tell me when I've got to stop. So how do you work in more of a project situation where you're working with someone who does kind of data analysis, maybe you're using Jupyter Lab or Jupyter Notebooks, that kind of thing. I'm going to show that now, a project that I've already created, and I used, instead of just uv-init to initialize it, I used uv-init -- package. So that creates a slightly different layout, and I'll show you what that looks like now. So let's go back to the right slide. So tree. So I've got a README, a PyProject.toml, a uv.log file. I've got a notebooks directory with a Jupyter Notebook in, and I have my source code that was in that myscript.py is now in a probability.py underneath a source directory and then a my project directory. So I'll show you what's in that probability.py. So cat source, my project, probability.py. It's the test coin code that we saw before, but now it's inside a function called test_coin. I'm going to cat py project.toml. So we've got similar metadata here. We've got some dependencies that we had similar to the ones we had before. But what's slightly different is below. I've added ipykernel as a development dependency. Means by default it gets installed, but you can exclude it on things like CI. This is useful because people tend to want to use VS Code to work with a project in UV. This will make sure that IPyKernel is installed and it'll let them work with notebooks. We've got what's called a project script set up here. This will allow us to use the shell command test-coin to run that test_coin function from within the probability, the myProject.probability package. And then we've got this build system section at the end, which is the way that UV realizes that it has to make that source probability test coin or probability.py file available within the virtual environment. Let's just have a look at the impact of what that is. So I use the UV run pattern again. Just type UV run. We get a list of sort of package executables that we can run, but we have the one that we've added, test coin. I'll run that now, UV run test coin. And that's a sort of simpler interface. So we've effectively created a simple command line interface. One of the cool other things though is, so let's say I come along and say, well, actually, I don't want to use VS Code to open my Jupyter notebook. I want to use JupyterLab and do it through the web interface. JupyterLab isn't a dependency, but I can run UV run. I can use --with to inject another dependency temporarily. So I'm going to inject the Jupyter package as a dependency. This will actually create another virtual environment with this package added, and then it'll throw it away again afterwards. So I'm going to type UV run --with Jupyter, and then the command I'm going to run is JupyterLab. So that will download and install Jupyter in a temporary environment, and it will be cached, so it'll be much quicker next time. And then it will run JupyterLab, and I can open and move Zoom out of the way. We'll open JupyterLab, and I'll just open that example notebook that we have. So there's my example notebook, and I'll open that probability.py file at the same time. Just move that over there. And to show you, the sort of the ease for especially someone that's not very familiar with Python, that test coin function inside that probability module, I can now just import because it's all installed in the virtual environment for me. I don't need to worry about playing with paths and things like that. And now I can run the probability.testcoin function, and I get the output that I expect. But another small quality of life improvement is if I was to change this testcoin function and then rerun it inside the notebook would still have the old version imported, and I need to restart the kernel in order to pick up the changes to the testcoin function. Except there's a small extension that's built into any kind of Jupyter, so this includes VS Code as well, called auto reload, and you can go %load x auto reload and then auto reload complete. If I run that, I can now make any kind of changes. So let's, I don't know, put in some asterisks in here on the right hand side, save that file, and if I rerun the cell on the left hand side without having to restart the kernel, it will automatically pick up the changes. So that makes it much easier for people. I think like people who are new to notebooks kind of tend to fall foul of that problem quite often. Okay, how would you do that in pixi? So it's very similar pattern, to be honest. What we use that's slightly different is the init pattern is pixi init format --format PyProject, which tells pixi to use the PyProject configuration. Not going to run that because I've already run it. So let's show you what you end up with. So we've got a pixi lock, a PyProject.toml, and then we have the same structure that we had before. And I will just quickly show you what is in that PyProject.toml. So we've got the kind of project, I've customized this a bit because just show up a few things, but we've got the same kind of project metadata that we had before. We've got the same fact that we're working on multiple platforms that we had before. If I scroll down, we've got the same kind of dependencies that we had before, but then the key bit that's been added is this. You'll notice there's this build system, which is the same as with UV. So we get it our project code installed as a package, and we also have the this section here under PyPI dependencies, which is needed to install our project as a package within that environment. The project scripts work slightly differently in Pixi, so I won't go into it in lots of detail, but you have this thing called project tasks. Effectively, they're like shortcuts. So it's a bit like having I guess, a make file or a just file or something like that if you've used those tools. Here we define a test coin command, and rather than running a function from Python, you actually put the shell command that you wanted to run. So here we're running Python source myprojectprobability.py. I've got another one here for lab that runs Jupyter Lab. So we should be able to see a demo of those. So pixi run test-coin. We've got that kind of output that we expected. Pixi run lab. That will launch Jupyter Lab for us. I'm not gonna go into it. So one other thing I'll show you is system-wide tools. So let's come out of. I've gone back to the UV installation here. Now I'm going to use. There's a fun package called cowsay, which draws a little ASCII art cow that's saying something that you're typing in. So the package is called cowsay. I can type UVX cowsay, pass the argument move to it. We'll download, install. It'll run that in a temporary environment. I get a nice picture of a cow saying move. That's without installing. So at the top there, UVX command or pixi exec is the equivalent in the Pixi world. Now let's say I actually want to kind of use cowsay on a more permanent basis. I would type something like UV tool install. For Pixi, it would be pixi global install cowsay. And now I can just run cowsay as a normal command. So I can type cowsay -t move again. Get a nice cow. So there's a few other examples. So if you follow the QR code on the slide at the end, which I'll just bring up, there's a few other video examples you'll be able to see. But I'm hoping that what I've at least argued to some extent is that you should probably go out and try these tools if you haven't already. If it's a new project that you're working on, certainly new projects that myself and members of the team have been working on, we've given these tools a go. When we've been working with people who aren't very familiar with Python but are kind of learning it, although it seems like it's another layer for them to learn on top, actually what we've been able to say is, in one example, with someone we've been working with, just run pixi run dashboard, and then they get their Streamlit or Shiny dashboard that comes up, and that's actually made it much easier for them. So yeah, that's me. Thanks very much.
Thanks so much. I for one was new to Python, and a colleague showed me UV at the beginning, and I've learned loads of extra stuff. So thank you. So, I mean, the top question is still, what is the tool you used in your presentation?
9 people. Okay, if you follow the QR code, the repo that has all the slides in also has the way that all of that's created. There's Docker containers for each demo that have the specific things pre-installed. Well, effectively, because I'm demoing installing a tool, I already have a tool and I don't want to uninstall it. So I start with Docker containers with nothing in them. And then there's a program called TTYD, sort of a terminal daemon, that probably very insecurely exposes a terminal over a port on localhost. And then in the set of slides, there's a frame that has that in it.
Amazing.
If you understood that, then you probably do it yourself.
Thank you.
That's why it kept breaking.
So the next question is, do UV and Pixi integrate well with IDE, which link against environments like VS Code?
So in the beginning, not very well. Now, much better. It could still be a bit better. If you're using UV, by default, it creates the environment in the .bn folder, and VS Code that's like one of the places hard-coded into VS Code that it will automatically look for environments. So if you're just running script, it should find that. If you might have to go to collect interpreter. What I tend to do is I tend to launch VS Code from a terminal, and I type uv run code dot, and then that will launch VS Code effectively with the environment activated already, and it should help it find it. If you're using a Jupyter notebook, you'll need that IPyKernel package installed as well. And this is where it falls down a little bit. I tried it the other day. It might find the correct version of Python, but if it doesn't have, if you don't have IPyKernel, VS Code will try and install it for you, and it will try and use pip to install it. But if you've created your virtual environment using UV, you won't have pip installed, and then it just doesn't work. So that's why I like to just make sure it's already installed already.
Great. So what are the arguments for choosing UV or pixi for a project and vice versa? And can I just add into that, because a lot of people use poetry, it seems similar. So why these over poetry?
So if you're using poetry at the moment, then clearly you know about how these tools work. So I would say you might just want to stick with using poetry. What UV gives you over poetry, for one concrete example, is it will install versions of Python for you. But with poetry, I think generally you use something like PyEnv if you want different versions to install them. Arguments for using one over the other, I mean, for me, it would just be if you're only using PyPI packages that would normally pip install, just use UV. If you want to use Conda packages, use pixi. If you're using Conda and PyPI packages with pixi actually has UV embedded into it that it uses to install PyPI packages as well.
So the next question, I think you briefly mentioned it in your talk, but it says, how do you feel about putting the log files into version?
Yeah, good question. I could have made this clearer. So if I've got, say, in my world of doing kind of data analysis and data science, if I've got something that I want to be reproduced completely, say it's a publication, I want generally the exact same versions that I used in that analysis. I would like people to try and use for recreating that analysis. So in that case, I would put both the log file and the manifest file in the version into version control. If it's something like a package, like when you go UV add and you install something, by default it uses kind of a lower bound on what the version needs to be. So say I go UV add pandas, it will say pandas greater than or equal to the version currently available. So it will allow it to be upgraded in future, but not. It'll make sure it at least has the features that you have today. If you're developing a package, that's probably the functionality that you want. But if you're developing an analysis, you probably want to put them both in.
Next question, I think you slightly touched a little bit as well. What's the best way to work with multiple environments for one project with pixi? Are you dev, test, and production environments where packages different?
I glossed over this massively. It was in that example PyProject example for pixi. You create. I'll probably get this wrong around. You create there's environments and features, and you create sets of features. I think it is that have packages, and then you add those to an environment to say, it's that way around. So you can have an environment that, say, is for testing, and that environment can have certain features activated within it. I'm not quite sure why they chose this, because I think it would have been better just to have a single layer. Having the like 2 layers, things gets a bit confusing. But you'd have maybe you'd have like a code quality feature that might have PyTest installed in it, and it might have PyLint installed in it, and things like that. And then you might have a formatting feature that has rough installed in it. And then you might have a development environment that says, oh, I'm going to need code quality, and I'm going to need formatting, and I'm going to need everything else. And then what pixi will do, my understanding is that it will make sure that whatever it gives you in the log file at the end of the day means that you'll get the same versions in the different environments that you work in. So make sure that they would be compatible together. And there are various options to turn all that off if you want to.
I guess similar to UV?
Yeah, UV, you create, it's just like the single layer approach. So a bit like when you pip install a package and then you put the square brackets at the end, you can specify optional groups. It has that approach to it. So you can create multiple ones there as well.
Right. Is UV like poetry, where it is effectively just creating a virtual environment somewhere that is automatically activated when in the directory containing the UV lock? I find it difficult to create CLIs with tools like this, unlike Conda.
Interesting. So, so the question at the beginning is, and also people might differ in their opinions. So feel free to like do another question with a correction. But is it like poetry where it's effectively just creating a virtual environment? So it is. It's got very similar features to poetry. So it will manage that lock file. It will create the virtual environment. It will activate it for you. Yes, but it also does Python install Python as well and has that pipx pipe global install functionality and some other bits and pieces. Probably a bit faster as well. So the second bit, I find it difficult to create CLIs with tools like this. So I would be very interested from this person, maybe on the Slack afterwards, to find out why you find that difficult. I'm not saying it isn't difficult. I want to know just what all the like pain points are for when we do training in the tools, and then why does Conda make it easier? So that would be be really intrigued to know.
If they're in the room,
come up to me, afterwards, or just shout.
Yeah, if whoever wrote that is in the room and wants to, maybe we could address it now. No, that's okay.
Or after, that's fine.
Okay. Workflow managers like SnakeMake integrate with Conda as a software version management tool. Are there any prospects of UV or pixi being integrated with these tools?
Yeah, short answer is that I haven't used SnakeMake, but colleagues have, and I know that it has quite tight integration with Conda. I don't know the answer. If anyone does know the answer, again, I'd be interested to know.
Okay, next question is, how can I use pixi to define both a developer environment and a Conda build, Rattler build recipes for end user packages using a single common list of dependency pinning version constraints? That was a lot of information.
I'm not sure because I haven't. I lost that halfway through the question. So how can I use pixi to define both the developer environment and Conda build recipes? So I haven't got much experience in actually doing building of packages through these tools. So I probably can't answer that one. It's going to be my quick answer.
Okay.
But I could still be happy to talk about it.
And just again, thank you to all our speakers for the reusability and reproducibility session. So we had Ian McKinley, Florian Zila, Simon Smart, and James Tunnell. So thank you.